Dear students, in previous class we discussed about conic sections. In that conic sections we discussed the four topics and four chapters. Each topic contain one chapter. So first before conic sections, first we discussed about straight line and then circle and parabola, ellipse, hyperbola. So these are all under comes coordinate geometry. Now we will learn another unit, that is calculus. In that calculus, a chapter that is functions and limits, and this chapter is foundation for the next chapter, that is differentiation. So this is the basic for differentiation. So this is a basic chapter, and if we know these basics, we will easily understand the concept of differentiation. So let us learn, and this is comes under calculus. So one unit is up to now we discussed, that is coordinate geometry. Now this is we are entering into another unit. So this is calculus. In that calculus, the chapter is functions and limits. So here we learn what is function and what is limit, and we will discuss, and we know some formulas or rules and some problems also. Let us see. Functions and limits. The chapter name is functions and limits. Objectives of the class. On the completion of this period, you would be able to know the various types of functions, different types of variables, definition of limit value of the function. So functions. Let a set is indicating a, capital A, and in that set we have one element, that is x, and take another set, that is b, and in the b set we have one element, that is y. See here, you can see the diagram. Two sets are given, a and b, and the elements are also given, and each set contain one element. So in a we have x, and in b we have y. So two sets are given, and that background shaded color is blue. Now these two sets we are connecting with an arrow mark, and mentioning it is a f. So we are building a relation from a to b, and that f is reflects as a function. So f means here function. So f a to b is a function, and it is showing that x to y. So the definition is let A and B are non-empty sets. Non-empty means it contains at least one element. A function into B, we mean a rule that assigns to each x belongs to A. There exists a unique element y belongs to B. So we are connecting, or we are showing, or we are giving a particular value from set A of the element to set B. That means in the set B, every element contains a particular relation or particular or corresponding value in A set of the elements. So here in a set, x is belongs to A and y is belongs to B, and here the y is connected with x which is in a set of A. So this type of relation or connection or the rule, like in a set B, each element is connecting with or bonding or having a relation or corresponding value or element in A, then that is called a function f A to B. So here we can say y equals to f of x. So this is a function, and here definition is given in a parrot color background shaded. So the two sets must be here non-empty sets. That means they must contain at least one element. See, f, here we see f A to B, or we can say function f A to B. F is a function A to B. Read as function f maps A into B. You can read it as a function f maps A into B. Means element x of A corresponds to an element y of B. So we can read it as f A to B, or f maps A into B. It is written as f of x equals to y. So y is belongs to B set and x is belongs to A set. So here the relation we made, it is f of x equals to y. So the A to B function is built, we can read it as f maps A into B. Function f maps A into B, or simply we say function A to B. F is a function A to B, from A to B. Or we can say, we can read function f maps A into B. So types of functions. Here generally we can categorize two types we will discuss here. That is, one is algebraic functions and second one is transcendental functions. algebraic functions in polynomial. A function of the form y equals to a naught x x power n, a naught into x power n plus a1 into x power n minus 1 plus a2 into x power n minus 2 plus up to so on plus an. So if a function is in the form of a polynomial in the form of y equals to a naught into x power n plus a1 into x power n minus 1 plus a2 into x power n minus 2 plus up to so on plus an, where a naught, a1, a2 up to an are constants, is called polynomial function. In rational, a function defined by quotient of two polynomials is called rational function. Quotient of a function defined by quotient of two polynomials is called rational function. That is, y equals to 5x square minus 2x plus 1 by 3x cube plus 6x plus 2. Y equals to x plus 2 by x square plus 5x minus 6. So irrational, a function of the form under root of x square minus 1 which involve fractional power are called irrational functions. Functions of the form under root x square minus 1 which involve fractional power are called irrational functions. Here under root we can write as a power 1 by 2. So x square minus 1 whole power 1 by 2. So the power is here in the fraction. So then it is called irrational functions. Number 2, polynomial functions, rational functions and irrational functions taken together constitute algebraic functions. So these are all comes under algebraic functions. So polynomial functions means like an equation y equals to ax square, like that. Irrational functions means like fractions, x squared by x or x plus 2 by x squared plus 3, like this. And irrational functions we already knew, and you can see here above line. So these are all it is containing or constituting or constitute, we can say it is a algebraic function. Transcendental functions. Functions include trigonometric, inverse trigonometric, logarithmic, exponential and hyperbolic functions are known as transcendental functions. So, if the function contains trigonometric or inverse trigonometric or logarithmic or exponential and hyperbolic functions are known as transcendental functions. Trigonometric means sin x, cos x, tan x. Inverse trigonometric means sin inverse x, cos inverse x, tan inverse x. Logarithmic means log x, log y. Exponential means e power x. And hyperbolic functions means sin hx or cos hx. So these are known as transcendental functions. Only x or y or x square or x cube or with constant like this we can say it is an algebraic functions. So here the example is given for transcendental functions. So, two examples are given, that is y equals to sin x plus cos x, and another one is y equals to log of x plus 1, and etc. And some more also given. Another example is y equals to e power ax plus b. Another is y equals to sec inverse x. Another example, y equal to sec hx. So here everything is covered which are above given functions are different terms we are expressed here, or we are given examples. Any function is either an algebraic function or transcendental function. Constant function. If f of x equals to k for all x where k is constant is called a constant function. So here the function may be a transcendental or algebraic. If it is defined like this, then it is a constant function. Example, f of x equals to 3. Next, explicit and implicit functions. Explicit function. Y is expressed directly in terms of x. Implicit function. Y is not possible to express directly in terms of x. Y is not possible to express directly in terms of x. So if we express it directly, we say it is an explicit function. If it is not expressed directly in terms of x, we call it implicit function. An implicit function is represented by the notation f of x comma y equals to 0. An implicit function is represented by the notation f of x comma y equals to 0. Example: x square minus 3xy equals to 0, and y equals to 0, and x cube plus y cube plus 3xy equal to 0 are implicit functions, since we cannot find y in terms of x. So in the example at beginning, it may be some printing mistake, but observe the second, that is x cube plus y cube plus 3xy equals to 0 is implicit function, because we cannot find y in terms of x. Even function. See, a function f of x is said to be an even function of x if f of minus x equals to f of x. Example: f of x equals to x power 4 plus x square minus 1. That is f of minus x equals to, here we are taking minus x in place of x. So in the right side also it reflects same, minus x whole power 4 plus minus x whole square minus 1, that equals to x power 4 plus x square minus 1, that equals to f of x. Odd function. A function f of x is said to be an odd function of x if f of minus x equals to minus f of x. Example: f of x equals to 2x cube plus 5x. We kept minus x in place of x, that equals to f of minus x equals to 2 into minus x whole power 3 plus 5 into minus x, that equals to minus 2 into x cube minus 5 into x, that equals to, take minus common from both the terms, 2x cube plus 5x, that equals to minus f of x. In the even function, same, if we substitute again we will get the same function, that is same question, f of x, but in the odd function we get minus into f of x. So we get the same function, that is even function. If minus into f of x, then we say it is an odd function. So for both the case we are taking minus x to test it is even or odd. So after substituting minus x in place of x, and after simplifying, if it comes the same question or same function, then it is even. If minus f of x came, then it is odd. If both are not came, then it is not either even or odd. So there is a three chances. It is the given function is or even or odd or normal. That means none of these two, that is even or odd. Variable. A quantity which changes subject to variation is called a variable. Variable means the definition here you can see a quantity which changes subject to variation is called a variable. Example, age of a person. So every person is not a same age. So different persons, different ages they have. Velocity of a freely moving body. So there are so many objects and their velocity also differ, etc. So see the table here framed, that is in the background colored parrot color background. At the top we can see variable, and this is divided in two ways. The left side, the pink color background showing independent, and the right side blue color background indicating dependent. So we can see the two types of variables, independent and dependent. Suppose y equals to f of x, that equals to 5x minus 2. Here x comma y are variables and x is independent. Here x comma y are variables and x is independent variable, y is dependent variable. Because if we observe, that is y equals to 5x minus 2. So y is depending on x because it is expressed in x terms, 5x minus 2. So whenever x changes, automatically y value will be changes. So y is called dependent variable because y is depending on x values, and x is independent variable because we can take any value of x. For every x, automatically y is changes. So here x is independent variable and y is dependent variable, but both are variables. At the final we can say x and y are variables. 5 and 2 are constants. In that variable we can categorize the two types, whether it is a dependent or independent. Constant. So in a function there are variables and constant terms. So sometimes variables and constants are we can see as a product or summation or subtraction or division, whatever it may be. So let us see the constant definition. A quantity that retains its value is called a constant. That retains its value means it is a fixed. If you said 2 means it is a 2, not a 3 or not a 1. So that is a fixed value, and it is called as a constant. Example, number of days in a week. So in a week we have 7 days. So in every place, a week means 7 days. So in every country, if you ask a person, the reply comes only 7. Next, number of months in a year. In a year, we have 12 months. In the same way, if you ask any state, they also said 12. And if you ask any country, the country said 12 only. That means the fixed number comes, so that fixed or unchangeable value, that is called a constant. Suppose y equals to 5x squared plus 2x minus 9 is a function. Then 5, 2 and 9 are known as constants, because we are seeing and we know the values. But x and y are, we cannot judge its value. We cannot say, or we cannot give a fixed value for x and y. So x and y are called variables, and 5 to 9, these numbers are called constant. Continuity of a function. A function f of x is said to be continuous at a point x equals to a. At a point x equals to a, if limit extends to a, f of x equals to f of a. Limit x tends to a, f of x equals to f of a. Here LT means limiting, limit, and x tends to a. That means if x value is taken as a, or x goes to a, or x reaches to a, then f of x reaches to or goes to f of a. Limits. Suppose y equals to x squared plus 1 is a function, then you can see here the table is given with some values. In an x column we have 0.9, 0.99, 0.999, 0.9999. So every row having a one more 9, and y equals to f of x. F of x means x square plus 1. So if we substitute the x value in above function or equation, we get y value. For every x we get corresponding y. So if you put 0.9, then we get y equals to 1.81. If you put 0.99, then we get 1.9801. Like that, we can have the values for y. So if you observe, if x is goes to or tends to 1, near to 1 or 1, then y is tends to or y goes to or y reaches to 2. From the above table, we can say that y is nearer to a typical value 2, as x is nearer to a particular value 1. So x is going x tends to 1, then y is tends to 2. So limit of a function definition. See here, the definition is given in a parrot color background shaded. The limit of a function f of x as x tends to a is said to be L if for any arbitrarily chosen positive number epsilon, however small but not 0, there exists a corresponding positive number delta such that f of x minus L is less than modulus of f of x minus L is less than epsilon for all x such that 0 is less than modulus of x minus a is less than delta. So this definition is a little bit difficult to understand, but whereas if you observe the table in previous slide, we observe so that difference, if x is changes slightly and y also same changes, so if x is changes according to y also changing, we observed in the table. So this means that the numerical difference between f of x and L can be made as small as we please by taking the numerical difference between x and as very small. Where the above condition is satisfied, it is written as limit x tends to a f of x equals to L. So here x and a as very small. So if you understand the table, we can say limit x tends to a means x tends to here 1, and f of x equals to L means 2. So this is the limit definition. If you observe the table or if you understand the table, you can get the concept easily. Then you read or observe the definition, you will get the limit definition. You will understand the definition of the limit. Summary. Summary. In this session, you have learned various types of functions, different types of variables, definition of limit of the function. So let us see. Various types of functions means we discussed what is a function and what is even function, odd function, and mainly functions are categorized into two types: algebraic functions and transcendental functions. Then variables are also, we can categorize two types, that is dependent and independent. And definition of limit of the function. Quiz. F of x equals to x is a dash function. Options are even, odd. So two options are given. Is it even or odd? So f of x equals to x means, to check it is even or odd, we have to substitute the minus x in the given function. So if we substitute minus x in place of x, we get minus into f of x. So f of minus x equals to minus f of x. That means it is an odd function. Next, number 2. F of x equals to x square plus 5x plus 9 is a dash function, polynomial or rational. So we say it is a, see again third option also given, transcendental. So we can say it is a polynomial function. Or we can say it is a rational function. And third question, f of x equals to sine x plus, simply in the second option, for second question you can say it is a polynomial function. And third question, see here, f of x equals to sine square x plus tan inverse x minus 6 into cos x is a dash function. So options are algebraic, or irrational, or transcendental. Another option also given, rational. So we can say it is a transcendental function. So first answer is, the first question answer is odd function. And second answer is polynomial. Here the answers are indicating in a red ink. And third question answer is a transcendental function. So let us recall once again. The chapter name is Functions and Limits. Here we discuss various types of functions, different types of variables, definition of limit value of the function. So functions, see here the diagram, two sets are there. A set contains x and B set contains y. So the relation from A to B is indicating with F, pointing the arrow mark. So F maps A into B. Definition: let A and B are non-empty sets. A function into B, we mean a rule that assigns to each x belongs to A, there exists a unique element y belongs to B. So F maps A into B, read as a function F maps A into B. We write like F is to A, in A gives B, or A is arrow marking B, or A plus B, but we read it, we have to say it as a F maps A into B, or function F is A to B. This means element x of A corresponds to an element y of B. It is written as f of x equals to y. Types of functions. There are mainly two types. One is algebraic functions and another one is transcendental functions. So algebraic functions, in polynomial, a function of the form y equals to a0 into x power n plus a1 into x power n minus 1 plus a2 into x power n minus 2 plus up to so on plus an, where a0, a1, a2 up to so on an are constants, is called polynomial function. Next, in rational, see here another function. A function defined by quotient of two polynomials is called rational function. That is y equals to 5x square minus 2x plus 1 by 3x cube plus 6x plus 2, and another is y equals to x plus 2 by x square plus 5x minus 6. And irrational functions of the form under root x square minus 1, which involve fractional power, are called irrational functions. So polynomial functions, rational functions, and irrational functions taken together constitute algebraic functions. And these, you can see here, if these are included, then we say it is a transcendental. That means trigonometric, inverse trigonometric, logarithmic, exponential, and hyperbolic functions. You can see here examples also. So like this we discussed, and some definitions are already we learned in previous standards, or in 10th or first year also. So or in first sem, first year means first sem. So you read once again, and this information given in our textbook also. So see the textbook and read and observe the examples and try to do the problems which are given in exercise. And if you have any doubts, you can ask me or message me on WhatsApp, and we will discuss We will clarify your doubts, and we will discuss some more in next class. Thank you.